So we're going to continue with constructions today in Chapter 5.2. We want to construct the in-center of ABC. So an in-center is the point that is equidistant to all three sides. Okay, and the in-center is the point where the angle bisectors are going to intersect. So the construction here is basically you construct two angle bisectors. Bisect one angle, bisect the second angle, where those angles intersect, where those bisectors intersect will be the in-center. If you were to draw all three angle bisectors, they'll all three meet the same point. Point of concurrency is what that's called. But you don't have to do three angle bisectors to do it. Two will suffice. That'll find you the point. And the rest of the construction, what the fact is equidistant to the sides, if you recall, to be equidistant to a line object, line segment, ray, one of those things, you're going to be perpendicular to it. So first thing I'm going to do is construct two angle bisectors. Again, I'll whichever two angles. And then once I construct the angle bisectors, that will be the in-center. And then I also want to draw a perpendicular from the in-center to one of the sides and then construct a circle. And the circle should touch all three sides. The in-center is always inside the triangle. You saw from yesterday's homework, the circumcenter could be outside the triangle. So this will always be inside the triangle. We have to do it right. So first step is you grab your compass, and I'm going to bisect an angle. I'm going to just choose angle B to bisect. I'm going to place my compass point at B, open up my compass to a comfortable radius. The radius here does not matter what you pick, but just, you don't want to have like a really tiny radius. Just, give yourself a little bit of, you'll notice when you're using the compass, the wider open it is, the easier it is to draw a circle, right? So just make it comfortable. And you want to construct an arc on one side and the other side of the angle that you're bisecting. All right. You can make an entire arc all the way through if you want to. I usually just put a little piece of an arc on both those objects. Once you've done that, then you pick your compass up. You can use the same radius you want. You can use a different radius, but you want to bring your compass to the point of intersection of the arc and the side, and you're going to want to make an arc kind of in the middle of the angle here. So basically we're expecting this angle bisector to come this way, so kind of position your arc so you think it'll be within the angle bisector's position. Now, I did say any radius was fine there, but once you pick that radius, once you make this arc, the same radius needs to be used when you move down to the other point, and you want to intersect that. So, two marks that are the same distance away from B, and then a mark from this spot and a mark from this spot, the same radius to create that intersection of arcs. Then you get out your straight edge, position it at B, and line it up with the intersection of the two arcs and connect the points. So that is the angle bisector of B. So what I know right now is that this little angle equals that little angle. All right. I typically don't mark that on my construction, but just to demonstrate, that's what I'm talking about. All right, so once we constructed an angle bisector, now I want to construct a second angle bisector. It doesn't matter which angle. I'm going to go with angle C. Get that out of the way for now. The exact same construction we just performed, so I'm going to place my compass point at C. I'm going to pick some radius. Doesn't matter what the radius is I pick. I'm going to mark an arc on AC. and I'm going to mark an arc on BC, the two sides of angle C. Once I've constructed those two arcs, now I'm going to move my compass over to one of these points. Again, I can use the same radius, a different radius for this. I'm going to go ahead and use the same radius. Place my compass right where the arc intersects the side. And I'm going to put an arc in here. And I'm going to move up to this other place where the arc intersects the side. And I'm going to place like that, and I'm going to mark an arc there. Okay, it's the exact same construction just did a moment ago. Then I grab my straight edge again. I place it at C, and I line it up through the intersection of the two arcs. Like so. And then I connect from C through the intersection of arcs. The point where those two intersect is the in-center. It happens to be right at the position of these two blue arcs intersecting. That's just a coincidence. That doesn't have to happen. All right. So I've constructed the in-center. Okay, the other part of the construction of in-center, it does say construct the in-center, but there's an expectation when you do an in-center to actually demonstrate the fact that it is the in-center by showing that it's the same distance from all three sides. So what I want to do is I want to construct a perpendicular segment from the in-center to one of the three sides. And last year when I first taught this, the students got mistaken that they thought it was a perpendicular bisector. It's not that, okay? I want a perpendicular segment from here down to here, or from here over to here, or from here over to there. It's not the perpendicular bisector. So what I want to do to construct a perpendicular from a point to a segment, let's say I want to go perpendicular to AB over here. Doesn't matter which segment you go with. I'm going to position my compass on the in-center. I'm going to open up to a comfortable radius. It has to touch both sides though, so you can see I've got more room coming this way than that way probably. So I'm going to slide my compass around. It's a little bit big, so I need to come in a little bit. I need to be able to intersect that side. So that's going to intersect the side in a couple places. All right. So our goal here is to be able to intersect this side or this side or this side. It doesn't matter which side you go with, but just you want to intersect the side. So I'm picking AB, so I'm going to put a mark on AB and a second mark on AB. And those two green marks that I just made are the same distance from AB to the in-center. That's the key. And now, imagine we have a segment that goes from this point of intersection to that point of intersection. I want to bisect that segment perpendicularly. So I'm doing the perpendicular bisector of basically this little green segment here. You imagine that segment there has endpoints. I want to bisect it. Using our normal perpendicular bisector construction, which would be place compass at one of the points, open up compass to bigger than halfway. So again, if I'm right here, if I'm sitting right here at this point here, halfway is kind of about here, so this is beyond halfway. I want to place an arc on one side of the segment and on the other side of the segment. And then I grab my compass, bring it over here to the other point of intersection of arc and side. Turn right on it. There we go. I'm going to intersect the arc there. I'm going to intersect the arc over here. Those two marks represent points on the perpendicular bisector of this segment here. So I want to draw the intersection segment here. And all I want to do is draw from the in-center through that. So you should see that if If you do it right, it should be touching the end center. If this doesn't go through the end center, you did that part wrong. As you can see, mine's going through the end center soil as well. So if I just connect those, and again, I simply want to go from the end center to the side. Okay, that is a perpendicular, like so. And the final step of the construction then is to create a circle with this radius. So I'm going to get my compass back out, and I'm going to place it on the end center. I'm going to open it up so it matches that radius. Like so. Let's make a purple circle, that'll be fine. And then just draw a circle, and you should see that that circle is going to touch all three sides, and I'm off by a bit. That's experimental error. I'm going to blame it on my tool. Maybe I'm off just a smidge here. Let's see if I can get a little closer. There we go. And again, it's not perfect. This compass is kind of jumping. Every time I move it a little bit, it jumps a lot. So it's hard to get right on it. You guys with your paper and pencil one should be a lot closer.
I didn't get close at all on this thing.
Let me look.